Okay, so we're going to go through this 2017 Christchurch Media paper, section B now. So let's look at the first question. Gravity light is an innovative device that works by connecting an elevated weight to a pulley system that slowly powers a generator as the weight falls. So as the weight comes down, okay, this pulley system with a built-in generator will actually cause the light to up. Okay, the generator will supply electricity to power a LED light. So this is called the gravity light device. Okay, so it says the weight, the weight here has a 12.5 kg and is lifted 1.8 meters above the ground. Calculate the gravitational potential energy possessed by the weight. So GPE is what they want you to find. The formula for GPE is mgh. So M stands for mass is over here, 12.5. G is given in the question, 10 Newton per kg, that's the gravitational field strength. The height is 1.8. Okay, so what you're going to get here is actually 225 joules. So the first question, 11A part 1, is the amount of gravitational potential energy is 225. Next one, it says the weight takes 30 minutes to fall back to the ground. Calculate the maximum power generated. So power is equals to energy divided by time. We have calculated the gravitational potential energy. Okay, the time here is 30 minutes. So take note, when you use E over T, the time here must be in seconds. So 30 minutes need to convert to seconds. So this is equivalent to energy is 225 divided by 30 multiplied by 60. Okay, so power equals to 225 divided by 1800. If you were to press this in your calculator, what you're going to get is 0.125 watts. So power, the units is in watts, W. So 0.125 here. Another 2 marks in your pocket. They say the LED light has a resistance of 90 ohm and it operates at a voltage of 2.7 volts. Calculate the current flowing. So you got resistance R, you got voltage V, they ask you to find current I. So actually look at all the three variables here. The formula they're going to use is V equals to IR. So V is 2.7, I is what you want to find, R is 90. Therefore, I is equals to 2.7 divided by 90. So I is equal to 0.0300 ampere. Okay, this is in 3SF. So 0.0300 ampere. Now, they ask you to calculate the power consumption of LED light. So what's the power consumption of the LED light? Okay, so I got current, I got voltage. Power in electricity, you actually learned it, is P equals to IV. So power can be calculated using the current flowing, which is 0.0300, multiplied by the voltage of 2.7. Okay, so you take your calculator, so you're going to get 0.0810 watts. 0.0810 watts. Okay, this is also in 3SF. Now, it says with reference to A part 2 and B part 2, explain why there's a difference between the power generated by the falling weight and the power consumed by the LED light. So if you look at the question here, the weight falling down, you actually have a power of 0.125, but the LED light actually only so-called have a power consumption of 0.0810. So it's a 0.125. This is the weight falling. If you, but then what happens is that it's not, when it's converted into the LED here, the power consumption is 0.0810. So you realize in terms of the energy conversion, 0.125 only converts to 0.0810. So there's some missing power. Okay, there's some missing power. So the question is, why is there a difference? So energy is lost to the surrounding. Okay, now the question is, how is it lost to the surrounding? Energy is lost to the surrounding as heat due to the friction occurring or experienced at the pulley. Okay, so if you look at it here, so you know that there's a pulley system here. So you realize that the rope here will actually, experience some sort of friction. And whenever you have friction, okay, you actually have heat generated. So the friction experienced by the pulley actually will cause energy to be lost to the surrounding as heat. So this is actually 10 marks, and actually you realize it's not too difficult to get marks once you understand the context. Next question, question 12. The Pavegen technology is a flooring system. As people steps on the tile, their weight causes electromagnetic induction generators to be displaced vertically, which results in a motory motion that generates electricity. It sounds very cheap here, but in general, idea is that when people step on it, you actually generate electricity. So step on it, you generate electricity. That's the key idea. Now, this shows the dimension of a Pavegen tile. So Pavegen is a tile that is 0.60 meters by 0.45 meters. So they say when a person with a mass of 75 kg steps on the Pavegen flooring, the tile is vertically displaced by 3 cm. First thing, let's calculate the weight of the person. I think this is not too difficult. W equals to mg. The mass is 75. The weight, then g is actually 10 as indicated here, so it's 750. Okay, now calculate the pressure exerted by the person on the tile, assuming that the person's feet occupy only 10%. So first thing, pressure is actually force over area. Force over area. So the force that's experiencing, there's the force that's being exerted on the tile is actually by the weight of the person. So it's 750. The area is the area of the tile. So 0.60 multiplied by 0.45. Now this is not the end because you need to remember that the person's feet only occupy 10% of the Pavegen tile. So I need to multiply this by 10 over 100 to show the 10%. So what's the pressure that is going to be experienced over here? So calculator, what you're going to get is 27777 Pascal. Okay, actually it still continues, but to round off, because they know the answer should be left in three significant figures, so therefore 27800 Pascal. So the pressure here is 27800. Okay, so 3 marks here. So quite a simple 3 marks. Next one, calculate the work done due to the vertical displacement. So work done is actually equals to force times the distance. Now, if you look at this whole question here, the only force that you have calculated so far, or that you know, is actually the weight. So remember that the weight is actually a force. It is the gravitational force, to be more precise. Okay, so if I know weight is the gravitational force of a person, so I know that this is the force here, definitely I need to use 750. Now, the vertical displacement, D stands for the vertical displacement. So we know that the vertical displacement, as mentioned in the question, is 3 cm. So I'll multiply here by 3. Now, but for work done, the force is in Newton. The distance here must be in meters. So I cannot use 3. I need to convert 3 cm into meters. So 3 cm is how many meters? So you convert it, you actually divide by 100. You actually get 0.03 meters. So actually, I should take 750 multiplied by 0.03. So what am I going to get? So I'm going to get the work done of 22.5 joules. Okay, so that's the work done. Now, using your answers from B part 1, determine the duration which a 0.5 watt lamp will light up. So B part 1, I know the work done is 22.5 joules. The duration which is 0.5 watt. 0.5 watt is actually power. So I got energy, which is work done. I got power. You're going to find the duration, which is time. So how is this three all linked up? You know that power is equals to energy over time. Energy, work done is a form of energy. So I know that this will actually leads to 0.5. It's actually equals to 22.5 divided by time. So let's do a little bit of math. T comes up, 0.5 goes down, so 22.5 divided by 0.5. So what I'm going to get here is actually the answer, 45 seconds. Okay, so the time calculated here will be in 45 seconds. So when a person steps onto the tile, okay, it will actually cause a 0.5 watt LED lamp to light up for 45 seconds. Okay, next, a student tries to replicate a component in the Pavegen flooring, because actually if you read carefully it's about electromagnetism. So this is the component here. So I put a steel core inside the whole thing. They say the component can be further improved by increasing the magnetic field strength. Suggest two ways to increase the magnetic field strength of the component. So this whole diagram here, I want to increase the magnetic field strength. What are the two ways? Look here, this is a steel iron core. Generally, to increase the magnetic field strength, I shouldn't use steel. I should use an iron core. So the first thing I do is use an iron core instead. That's the first thing I could do. Second thing I can do is increase the current flowing through. Right? Flowing through the coil. Okay, now third one, what I can do is to increase magnetic field strength. Actually, by increasing number of coils, I also increase the number of field strength, the magnetic field strength. So the third thing I could do is to increase the number of coils around the core. So these are the three. You can use any of two. My suggestion is go for the first one and go for the third one. Okay. Why second one? Try not to use it because this is the idea of electromagnetic induction. Okay, the current component there is a little bit more complicated than what you have learned so far. As such, that's why my suggestion is 1 and 3. 2 is a possible answer, but in the actual application in terms of the device itself, 2 may not be that applicable. Okay. Now let's go next one. 13. Zobbing is a recreational activity involving a person rolling down a hill inside a plastic orb. So this is a plastic orb. Person inside and then roll. Go down. Okay. Figure 13.1 shows a person with a mass of 60 kg in a zob preparing to roll down the gentle slope. It says the person in the zob rolls down at an acceleration of 2 meters per second square from rest. From rest means that the starting speed is 0. It's 0 meters per second. Acceleration 2 meters per second square means that the speed increase by 2 meters per second every 1 second. Okay, the time taken to reach the base of the slope is 10 seconds. Find the final velocity of a person in the zob when he immediately reaches the base. Now, once there's an acceleration, most of the time to find the final velocity is not that simple. So my suggestion is draw a graph. Whenever you have such question, you start off from rest. Okay, 10 seconds later, is the velocity, this is the time. What is the final speed? So what I know is, okay, so let me draw this. Okay, I know this slope here will give me 2 meters per second squared. How to calculate the final velocity? The acceleration is actually equal to final velocity minus initial velocity divided by the time taken. So I know acceleration is 2. Final velocity is v, the one that I'm going to find. U is rest, so it's 0 because I start from rest. And time taken is 10 seconds. So if you were to do your math, v equals to 20 meters per second. Okay, this one is not supposed to be time taken. My apologies. This is with velocity. It is supposed to be meters per second. So this one here will be 20 meters per second. On the axis, sketch the speed time graph to show the motion. Oops, don't need to sketch there. Can sketch over here. So start off at 0. 10 seconds later, the speed becomes 20. Okay, so and because we know it's constant acceleration, so this will be a straight line. Okay, let me use a ruler to draw this. Okay, on my screen here, I'm going to take a ruler. I'm going to draw a straight line like this. Okay, so this is the sketch of the speed time graph to show the motion of the person in the zob. Now let's go on to the next one. Calculate the distance from t equals to 0 to t equals to 10 seconds. So what's the distance traveled over here? Now, so for a speed time graph, to find the distance traveled, okay, it's actually not to take the speed times time, but what we're going to do, we're going to use area under graph. So generally, whenever you got kinematics question, my suggestion is whenever you want to calculate distance and you want to find the distance traveled, use area in the graph. So I'll need to find this area over here. So I'll take a half because it's a triangle. So it's a half times the base, which is 10. The height is 20. So what I'm going to get is 100 meters. So the distance traveled is 100 meters. Lastly, calculate the kinetic energy possessed by the person at 10 seconds. So at 10 seconds, I know the speed is 20 meters per second. I need to find kinetic energy. So Ke equals to half mv squared. Half times the mass is 60. Okay, right at the very start, they did mention that the mass of the person is 60. The velocity of the ball is 20. Okay, velocity is 20, right? Yes, 20. I square this. So I'm going to get is 30 multiplied by 20 squared. Sorry. I just press your calculator lah. So if you press your calculator, the kinetic energy possessed is actually 12,000 joules. So kinetic energy, 12,000 joules. It says the zob can be modified to generate electricity from its rolling motion. By making 350 turns, the zob can generate sufficient electrical energy to power a 100-watt light bulb for 1 hour. 100 watt light bulb for 1 hour. Calculate the energy needed to power a 100-watt light bulb for 1 hour. So you're thinking, sure, this 350 turns got any difference? Before we go into that, let's look at the question. You see, it says to calculate the energy needed to power a 100-watt light bulb for 1 hour. And you see E, P, and T. Once again, the same formula is applied as coming out. So power equals to energy over time. Do I need to care 350 tons? No. So the power that I have, it says 100 watts. Energy required, I am supposed to find it. The time here is 1 hour. So 1 hour here. But take note, the time should always be in seconds. So I must take 1 multiplied by 60 to convert to minutes. Multiply by another 60 to convert it into seconds. So therefore, E is actually equals to 100 times 1 times 60 times 60. What are you going to get over here? You're going to get 360,000 joules. Okay, so the final energy here, 360,000 joules. So that's all for section B. Okay, so if you have any questions, remember, look for your teachers. Okay, or you can, get them to teach you more on these questions if you have any doubts. Okay, that's all.